If you take anything other than one box, I'm sorry, you are just simply wrong. I am going to be rich and you are going to be poor. And that is a fact of the matter. It just is. Just by saying you should take 2 boxes, you've already sealed the deal of being poor.
Hello, welcome to Mental Reps. I'm Fish.
And I'm Ben. Today, Fish is going to get quizzed on some tests.
I am ready.
They're not tests. They're just mind puzzles. Some of these are paradoxes that actually have answers. And some of these are paradoxes that don't have a definite answer, but are...
I'll find one.
Well, and you're going to be wrong. So, let's just get right into them. So, the first one. The Wason selection task.
Oh. All right, that sounds legit.
Yes. Now, I need you to think here. I need you to make a mental image because I'm going to try to say this in a way that is audio listener compatible. There are 4 cards in front of you, analogous to playing cards.
Yep.
Okay, 4 of them. Each card has a number on one side and a color on the opposite side.
Yep.
Okay. One card has the number 6 on it. And one card has the number 9 on it. Okay.
Mm-hmm.
One card has the color black. One card has the color black on it. And one card has the color white on it.
Okay.
Those are your 4 cards.
Mm-hmm.
And those are the faces that you can see.
Mm-hmm.
Okay. Which card or cards need to be turned over to test the rule? A 9 will always have black on the other side. Okay.
Which sides face up? The numbers?
The sides that I just told you.
Okay, so two numbers are faced up and 2 colors are faced up.
Yes.
Okay.
And the 2 numbers have colors on the opposite sides, and the 2 colors have numbers on the opposite sides.
And what's the question again?
Which card or cards need to be turned over in order to test the rule? A 9 will always have black on the other side. And just to reiterate, there is 6, 9, black, white in front of you. If you were to turn over the 6 or the 9, there would be a black or a white.
Well, so here's the
whatever.
thing. Here's the thing. So,
I'm ears open.
If you're testing the rule, if on the other side of a 9 there's always black.
Mm-hmm.
You would have to check at least one of those.
Yeah.
Because but do you need to check both of them? Well,
there's 4. What do you mean both?
Well, because one of them's got black on the other side, so you could flip it over to find a 9.
So you're saying, by both you mean what, 2?
The 9 and the black.
Okay. You didn't specify that. You just said both.
Oh yeah, I meant both of the associated qualities. Yeah. So I would say you flip over the 9 to see if there's black on the other side, and then if that's not proof enough, maybe you flip over the black to see if there's 9.
That is completely incorrect.
Really?
Yeah.
Okay. So, do you even flip over the 1?
There is no 1.
The 9? So I meant the 1 9.
Well, just what's your reasoning here? Just go through your reasoning out loud.
So
why are you flipping over the 9 and why are you flipping over the black?
Yeah. So the reason you flip over the 9 is to check the validity of the claim that there is always black on the other side of a 9.
Oh, you're right. So because if you were to flip over the 9 and there was a white, immediately the rule would be false.
Immediately.
So you're right. You check the 9.
Yeah.
And your other selection is completely incorrect. You don't need to check that card.
Okay. Do you need to
go through your reasoning as to why you checked that card? Why do you flip over the black?
To see if there's a 9.
And what does that have to do with the rule?
Well, because you would assume, if they're cards, you would assume that these are like a standard print kind of situation. So like there's always a 9 and there's always a black, no matter which orientation they're in.
There can be any number or any color,
but the black is always on the other side of the 9.
If the rule is true, which is what you're trying to test.
Right. So we've determined.
But anything can be on the other side of a black.
I don't know how that would be. So it does.
What are you testing by turning over the black?
Okay, I was under the impression that the card would be standard, right? If black is on the other side of the 9 is on the other side of the black. Is that not the case?
There's no okay. So there was if there was only the possibility if the cards were only these cards can have any number and any color on them.
I didn't because you're not getting why this is important. I get what you're saying now, but why this is important is if it were to be standard that one is on the other side of the other and the other side is on the one side of the one, you would need a double check, right? Because if you would have 2 qualities present for this rule, one on the side of the 9 and one on the side of the black. So you would need, in my opinion, you would need to check both to make sure, because you have a redundancy.
No.
Right, because now you've told me that isn't the case, that the black the 9 allegedly always has the black on the other side, but the black doesn't always have the 9.
Well, yeah.
So that doesn't matter. So you just need to check the 9.
No.
Oh, that's also not the case.
No. You need you need to check more than just the 9. But checking the black is completely irrelevant to the claim.
Okay, so it's a 6. It was a 6 was the other one, right?
Yeah, 6-9 black white.
6-9 black white.
So you need to flip over the 6 to test. So I'll tell you what you're doing.
Yeah,
what you're doing is you're taking the claim, a 9 will always have a black on the other side, and you are trying to flip cards to show that the rule is correct.
Mm-hmm.
You should not be doing that. You should be trying to flip cards to show how the rule is incorrect. You need to falsify the rule. Do what would immediately make the rule wrong, should it happen.
What would immediately make the rule wrong?
Well, you already got the first one. If you flip over the 9 and there's a white on the other side, that would immediately falsify the rule.
Right.
Which would mean... So go ahead.
So a black will always be on the other side of a 9. Is that how you worded that?
Yes. A 9 will always have a black on the other side.
Okay, so it is the other way. Okay. So you don't need... This is my theory anyway. You don't need to check the 6 because the 6... What is on the other side of the 6 is irrelevant.
Completely irrelevant. Yeah.
So the only other card to check is the white.
But why?
I guess it'd be to make sure there's not a 9.
Exactly. Because that would immediately falsify the rule.
Okay. I suppose, yeah. So you're saying you check the 9, then you check the white.
Yeah. The 9 and the white are the 2 cards that need to be checked to test the rule.
Right.
Yeah. Let me put this a different way that makes it so blatantly obvious.
Okay.
So you have 4 cards there's 4 people in a bar.
Drinking.
Well, actually, screw that. We'll go back to the cards. There's 4 cards in front of you. One side of the cards has drinks. And the other side of the cards has the people's ages. Okay. You're going to test the rule. Anyone drinking has to be over the age of 21. Or anyone drinking is over the age of 21. Okay.
Has their drinks? Is that what you said the first one?
Yeah, one side is drinks, the other side is ages.
Okay.
So which 2 cards need to be flipped over to test the rule? Anyone drinking is over the age of 21. Okay. 13. Soda. Beer. 25.
You need to check 13 and beer.
Obviously.
Yeah.
Yeah. And that was the exact same problem as what you just did.
Okay.
Yeah.
No, I get it now. Okay.
Yeah. It's so much easier when it's put into a social situation.
Yeah.
Isn't it?
So, okay, let's go through the original problem again.
Okay. So
6,
there's 6, 9,
black,
white. Yeah. And you're testing the rule, and 9 will always have black on the other side. And you need to check the cards that will falsify the rule rather than checking cards that just show the rules correct. And flipping black, like you said initially, which is what like over 90% of the people that do this. Also
okay, well, the only reason that I flipped black was because I assumed that there would be another side. It would have to be consistent, right? So I was checking for consistency on the 9 and the black.
Well, that's
connection.
not what the question was asking, though.
Okay, though I assume because it's a card, it was standard, but that was where I got that from.
Yeah, that's an incorrect assumption.
Okay,
an assumption that never should have been inserted into the thought experiment.
Okay, so yeah, well, barring that,
I still think you would have gotten it wrong because you did. But yeah, so you answered what the vast majority of the people answer, and I believe so. I had learned about this test in a different formulation because you can make this in a million different ways with different cards and different opposite sides.
Yeah.
I don't know. Mine wasn't numbers and colors. I think it was like letters and something else. But I'm pretty sure I had also gotten it wrong. And having come across it this more recent time, I in part remembered why I had gotten it wrong and then got it right this time. Only because I knew that whatever I think the answer was incorrect. So I knew
the obvious thing.
Yeah,
wrong.
I knew not to do the obvious thing. So I got it correct the second time. But yeah, it plays on people's intuitions to see a rule and then test things that agree with the rule instead of immediately trying to do what would show the rule is wrong.
Right.
Which is a much faster way to get to the validity of the rule or not. And flipping black is one of those things because flipping black has no bearing on the rule. In the same way that turning over soda, it doesn't matter who's drinking the soda, right? And it's so much more obvious in a social situation because that's how we evolved to think in social situations, not in logical notation.
Right. Yeah. I was just trying to relate it back to the drinking one. I think that makes a lot more sense. It makes a lot more sense when it's I don't know.
It's analogous to you flipping over the 6 and the black is analogous to you flipping over the beer and the 25-year-old to see if the 25-year-old is drinking beer because that would agree with the rule.
The 25-year-old is the black card.
Yeah. When in reality, you needed to turn over the white card, which was I guess that would be
that'd be the beer, wouldn't it?
Yeah, it'd be the beer.
Okay. No, yeah, that makes sense.
But for whatever reason, almost everyone just gets this wrong in when it's in logical notation like that. But almost everyone just immediately gets it right when it's in a social context.
But why do they get it wrong though? So everybody picks the 9.
Everyone always picks the 9.
Okay.
So of the answers that are disregarded with people that just say all of them, which is obviously incorrect because there's 2 that don't need to be turned.
Yeah.
Which people that answered those are just kind of usually answers are assumed as people are giving up. But of the ones that seem people actually answer, some people just say just the 9. The vast majority, like I'm pretty sure 90% plus say the 9 and the black.
But I wonder why though.
Because it's confirmation bias. This is people have a thing in their mind like a rule, and they want to test the rule by confirming the rule instead of immediately going against the rule. It's a thought experiment to expose confirmation bias within us. Because the same is true of so this is, I might butcher this a little bit, but there's another test that social scientists did where there was like black triangles and white triangles in a box or something like that. And people couldn't, the experimenter could see in the box and grab out a black or a white triangle. The contestant or the participant, it's not a contestant, it's not a contest. The participant was asked, they could not see what's in the box. The experimenter could. The participant was asked, test the rule, all the triangles in this box are white. And they would say, okay, pull out a white triangle. And he does. And they'd say, okay, pull out another one. And he does. And they say, okay, pull out another one and another one. And they say, oh no, seems like they're all white to me.
Yeah.
When to immediately test the rule, they would have to do is say, pull out a black one. Yeah. And if he pulls out a black one, boom, the rule is falsified.
Yeah.
But people don't do that. They just say white, 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 white.
Yeah. No,
don't clip that.
Like that illustrates that though. I think that's
yeah,
probably true.
It's a confirmation bias thing, which is weird. We have ideas in our heads, and for some reason, it's instead of trying to figure out the fastest way to see if our ideas are wrong, which would make them even more reliably right if we can't figure out a way that they're wrong. Instead of doing that, we just keep trying to figure out more ways that they could be right. Maybe that's a survival thing. I don't know. Perhaps that's evolutionary. Because confirmation bias is like one of the most... There's genuinely like not a single human being that doesn't like adhere to that on some level. All right, let's go to the next one. So this is a similar thing. So I'm gonna say a 3-digit number that it adheres to a rule.
Okay.
I'm making up the rule just on the fly. I'm not telling you the rule, but I'm gonna say a 3-digit number that follows this rule. Okay, and then you have to say subsequent 3-digit numbers, and I will tell you if it adheres to the rule or not. But after a few guesses, I'll make up a number on the fly.
I'm usually really bad at these kind of games.
You have to guess the rule.
Okay, this is going to be pitiful. All right.
All right.
Side note, this kind of game, I've never seen it with 3 digits, but this kind of thing is on like math IQ tests and stuff, like the math section of IQ tests, kind of like a understand the rule. Have you seen those?
Yeah.
Atrocious.
Some of those are tough though.
Yeah.
Some of those are like the digit is doubled each increasing number, or some of the rules. But here's the thing. That's also because I'm going to give... Okay, I'll be giving too much of a hint.
Don't do that.
If I spell that out. Let me just say, obviously, you know what Occam's razor is.
I'm blanking on what the name connects to, but...
Occam's razor?
Yeah.
All else being equal, simpler is better.
Oh, okay. Yeah, I forgot the name of that, but yeah, I've heard that. Just
think about that. That's a pretty big hint. But so 3-digit number. You have to figure out my rule. 468. That adheres to my rule.
So I got to give you.
Just spitball. I'll get. I don't know what number.
So you said 468.
Yeah.
Let's go 962.
No, that does not follow the rule.
358.
Yes, that does follow the rule. 358.
179.
Yes, that does follow the rule. That's 3 guesses so far. We'll say we can get to 5 guesses.
8, 3, 5.
No, that does not follow the rule.
All right. I gotta ask you this question here.
Okay.
2, 4, 6.
Yes, that follows the rule.
Is it ascending order?
Like just number go up?
Yeah.
Yeah.
Okay. I was gonna say that's.
Yeah. Yeah, it's just literally just number go up.
Yeah.
Yeah. But here's the thing. I said Occam's razor there is because people generally, if they heard 468, they're gonna be like, okay, ascending by 2s. They would usually the answer is much more complicated.
Well, so immediately I went to odd numbers because I was like, let's see if it's only evens, and then I think you said it was yes. After that, I was like, okay, so it has nothing to do with evens and odds. And then I went descending, and then you said no, and I was like, So then I went alternating. I went high, low, medium, and that was no. And then I went back to forward way, and then you said yes. I was like, okay.
Yeah. Okay. Yeah. So some people, they're going to get in their head like, is it ascending by 2? And then this is another confirmation bias test. And then they keep testing their own that. And then they get yes.
Yeah.
when it's usually a much simpler.
Well, if you keep getting yes, that means you're winning.
Exactly. All right. Dude, this one destroyed me. I was distraught trying to get this one. But I got it in the end. It took me a while, but I got it in the end. A lot of contemplation and thinking. Burger and fries.
Love them.
You should know this one good.
What is
I
that?
thought I would get this one like, I got it. But no. Burger and fries. The burger and fries. The burger and fries together. The two of them pair cost $1.10.
Mm-hmm.
Okay. The burger costs $1 more than the fries. So how much do the fries cost?
Okay, so immediately the gut reaction is to say that the fries cost 10 cents.
Right. Yeah.
That by how distraught you were, I'm guessing that's wrong.
Well, you can answer the question if it's right or wrong. Do the math.
So it's the burger is
You don't need me to answer it for you.
the burger is $1 more than the fries.
Mm-hmm. And you're trying to figure out how much the fries cost.
Well, if the fries cost 10 cents, well, that'd be wrong, wouldn't it? The math. Because if it was, hold on. All right. So if it's, well, if you do anything,
We just did a mental math episode, and I still took a long time to do this
I'm
calculation.
bad at math still. So yeah, so if it's, let's think that through. So if the fries were 10 cents, the burger would cost $1 more than the fries. So the burger would cost $1.10, making the grand total $1.20.
Yeah,
So that doesn't
it
make sense.
doesn't do it. But that's the intuitive. Obviously, work. Obviously, costs a buck. No.
And it's probably not some negative shenanigans.
No. This is. The fries don't cost negative money.
Hey, that'd be a deal though. I mean, a burger of fries for $1.10 is already a pretty freaking.
That's
good
all
deal.
right. Yeah. That's like some midget burger
You can't be saying that.
costing that much money.
Okay. Well, and if it's a, oh, good Lord. So if it's let's say it's 5 cents. So 5 cents. Oh, well, frick. Hold on. Fries cost 5 cents.
Yeah.
Oh, that's easy.
Yeah, except it's really not, apparently. They literally just cost 5 cents because that means the burger costs $1.05.
Yeah.
Put them together, you get $1.10.
Yeah.
It's that easy, but it's so hard.
Yeah.
Like, why is that so hard?
Good Lord. Yeah, I wanted to be, I kept wanting to go like, oh, it's 10 cents. And then I feel like I overcorrected. And then I thought it was like in the penny or 2 penny range. And then I was like, well, that doesn't make any sense.
No.
Then you're low there.
Right. Yeah, it's literally it's that simple. And it's impossible. I don't know why. I genuinely can't figure out an explanation as to why that's so wrong in our heads. I've looked around, like, why is this math equation specifically annoying?
Well, because...
And I can't figure it out.
Because I think it's because people, instead of associating that the burger's $1 more than the fries, they just kind of think it's $1 more. It's just kind of... And the fries are grouped in to that. You know what I'm saying? You know what I'm getting at? It's instead of it's $1 more. Here's what they're doing. They're not adding the fries back in at the end. It's $1 more than the fries, and then they're not adding the cost of the fries that they just associated the cost with back into it. I feel like that's part of it.
Perhaps the burger costs $1 more than the fries. Even when I say that, I want to think the fries are 10 cents and the burger's $1.
Yeah.
It has to do something with that and maybe how the question is worded. Because that's just bizarrely difficult for not an obvious reason. Okay, so the birthday paradox. This one's it's a little mathematical, not quite so overtly, but of a randomly selected group of people with no overlapping birthdays, okay, how many people are needed for a probability of 2 having the same birthday to equal 50% or greater? The closest number you can get to 50%. Probability of 2 randomly selected non-overlapping birthdays
of over 50%,
or I guess at least the non-overlapping birthdays. I mean that as like, that was poorly worded. I mean that as like, there's no baby boom scenario. There's no, most people have births around Christmas. There's none of that. This is all
relatively evenly distributed.
Evenly distributed. How much of a group do you need? How many people in a group do you need for the probability of 2 having the same birthday to equal 50% or greater? Closest number to 50%.
Probabilities are fricked.
So there's 365 options of birthdays.
So the obvious answer, we'll start there, is...
So 366 would equal 100%. Because 365, technically, you could still have one person on each day. No leap years, just to make this more simple. So 366 would equal 100%.
100% probability.
Yeah. Because it's impossible to have 366 people in a room because there's only 365 options of birthdays.
Meaning, because it's evenly distributed, that last person will share a birthday with somebody in the room. That's what you're getting at?
It doesn't matter if it's evenly distributed. Like, at 366 people, there is no probability. There just simply is no possibility that none of them share a birthday. It could be... Do you get what I'm... You don't look like you get what I'm saying.
The way you worded that, it was a double negative, and I had to... I was following along, but yeah.
Oh, yeah. There's a 100% probability that somebody has matching birthdays. Some 2 people have matching birthdays with 366 people. At 365, there's an overwhelming probability that people share a birthday, but there's also 365 days. So it is possible that all 365 people could have different birthdays.
Mm.
So that's why 366 is needed for 100%. But we're looking for just 50%.
Right. So half of 366 theoretically is 50%. But here's the thing. But that's not really... That's got to be wrong, though.
What is?
If
you're not speaking out loud enough.
Yeah, so if you're... What's half of 366? What is that? One... or no, that would... Yeah.
133. Sorry, that's 266. 366 would be 183.
So 183 is half of the year plus one, which was 100% probability.
Mm-hmm.
But if you just cut that in half, you could still very easily find your birthdays spread throughout the year in a way that does not match up. Right, to be matching. Like you know what I'm saying? It's but I guess I'd say that I can't.
So you're saying 183 people, there's a possibility that they could all be sort of shotgun blasted across the year such that they wouldn't have a birthday, of a probability of having a 50% or greater chance.
Yeah.
Okay.
But I can't think of another way to do that. So I guess I'm stuck. My reasoning skills are failing me. So
why don't you... just start from where you don't think that works. Why don't you think that works?
Well, just like I said, I've the way that's kind of could be distributed throughout the year.
Well, yeah, a 365 could also be distributed throughout the year to not have a matching birthday.
Right. So that's kind of where I was falling back. Maybe that is the case. It feels like it would still be lower than 50. I guess that's where I'm thinking.
At 183.
At 183 still feels lower than 50, but I don't know where else to go with that.
So that's your guess?
Yeah.
That's not right.
Yeah.
It's too high. Your reasoning is the opposite of what's correct. It's actually too high.
Oh.
That's like over 99% probability.
So too many. So okay. So now it's a too many sample problem. Too high of a sample. Because all you need is one hit on a matching birthday, right? So if you have too many people, you have a too high of a sample size.
Yeah, 100. I genuinely think 183 is like an over 99% probability that two share a birthday.
You know what? Now that I'm thinking about it, I feel like I've heard a statistic at one point where somebody said, like, if you get like 10 people, or like maybe it was 20 people, there was like a really high likelihood. It was like in that really low range. Say like, I don't know, maybe 50%, maybe 15 people.
Why though? Just spitting a number is not exciting. We need to know why.
Well, the reason is because I think I heard that statistic. But as far as why is concerned,
try to rationalize the statistic. Like how could that possibly be correct? Of 365 days, 15 people needed for a 50% probability that two equal the same 365 chance?
It's 12 months in a year. That doesn't help you at all.
I mean, if you're looking for the same month, that's a 1 in 12.
Yeah, that's pretty good, dude.
Yeah.
If you had 15 people, you're a lock.
You're right.
Yeah, I don't know. I don't have a rationale for that.
Well, the whoever somebody said that is correct. The answer is 23 actually. 23. So 183 would be like 99.999 to the power of like 20%.
That's crazy.
Like overwhelmingly large probability.
But the thing is that I can still very easily think of a situation where that it doesn't pan out that way. Like
you'd think.
Yeah.
Incorrectly. You can just because you can very easily think of that doesn't mean that that's probable. Because you're not counting the amount of people that have birthdays on the day. Like if you think of just a shotgun blast at a calendar, and which is how people think about this.
Yeah.
Then yeah, it's so easy to think about how there couldn't be two bullets that land on the same day.
How did you do on this one?
I got I was a little lower than yours. It was 100, like 100 something. It was like 120, whatever.
Yeah. Well, how did you come to 120? Was it just
pretty much the same thought process? I was thinking of shotgun blasting a calendar.
Yeah.
And I was like, yeah.
So you just
I didn't just take 365 days and then cut the deck in the middle like you did, but
to be clear, I assumed that wasn't right because that did in my mind seem way more. Or no, I guess I had it backwards.
You were reasoning in the opposite direction.
I did.
That was too low.
I said it was too low. Which now in context, that doesn't make any sense.
Well, you still don't know how 23 can be possible.
No.
It's because this doesn't work like a shotgun blast. We're counting the amount of pairs between people, which means 23 people. So for the probability to get way up, we're counting pairs between people, not people on days. Okay.
Mm-hmm.
And the amount of pairs in a group of 23 is like 250 something.
Mm-hmm.
Right?
Say that again. Group of pairs.
The amount of pairs between a group of 23 is like 250 something. Which is it's plenty to get to 50% probability.
Yeah.
It's because you're counting. So if John, Joe, Jill, and Jack, just let's 4. If there's 4 people, we've got John and Joe, John and Jill, John and Jack. That's 4 pairs. That's 4 options.
Yeah.
And then, well, you see where I'm going here. Jack and John and Jack and Jill and Jack and I've forgotten my J's.
But they're paired up.
We're counting pairs.
Yeah.
Okay. So in a group of 23, like if you draw a circle, a dotted circle of 23 dots to create a circle, and then draw a line from each dot, from every dot to every other dot, the circle is going to be completely filled in because there's so many, 250 something of them, in fact. So that's why this works. Is because we were counting pairs.
Yeah.
Even though it's so easy, like you said, how is that possible when I can easily think of? It's because what we can easily think of is just not a reliable indicator of what's actually true. Just because we can easily think about it. Like a 300 and a 200 people in a room. Again, this seems like, it seems more probable that they'd be sharing a birthday, but I can think of 200 spread across an even spread of a calendar and not matching. But with 200, there's so 100% minus 2 times 10 to the negative 28 zeros. So 0.027 more zeros, 2% chance less than 100%. So basically, beyond any reasonable doubt of a probability.
Yeah.
Which is 200 people. Which means if you had a group of 365, the probability is like the zeros are in the hundreds.
Yeah.
Like there effectively there is no chance that you would get a group of randomly selected 365 people with not sharing birthdays. Yeah. So, I don't know. I thought that one was... I don't know anybody that's ever gotten that right.
I don't like that one.
Why?
Because probabilities are freaking confusing to me. But it's interesting.
Well, I was gonna say that's not That's not confusing to anybody.
Yeah,
that's confusing to everybody.
That one was rough. But
Yeah.
I feel like I get it now. It's you counting. It's the pairs and not the people.
Yeah, right. And I everybody goes to the shotgun blast analogy.
Yeah,
everybody goes to it, and that's true. It is true, but they don't connect every. Yeah. So, all right. The Linda problem. We're gonna be talking about Linda.
Oh, what's Linda?
All right, Linda. She's 31 years old. Linda's 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. Okay. We aren't for that. We're pro-nuclear.
Well, what is nuclear? What nuclear energy?
I guess true.
Or
I don't know.
War or bombs.
Given Linda's profile, probably war.
I was gonna say if she's
then I'm pro.
If she's anti-nukes, then that's
anti-nuclear bombs. Then
pretty sick.
Yeah, then we're pro. All right, which is more probable? Linda is a bank teller, or Linda is a bank teller active in the feminist movement?
What does bank teller have anything to do with it then?
Which is more probable?
Okay, all right, we're just taking it as it is. So,
you ask those questions in these thought experiments, and that's what messes you up.
Yeah,
is asking questions.
I
want to
I want to know what's going on with Linda. All right,
like just take the thought experiment for what it is without adding more to it.
Well, what I was wondering about is you have a variable bank teller and feminist, and one is with bank teller without feminist, and one is with bank teller with. So when you phrase it like that, it makes me think bank teller is an important component here, but I feel like it's also not. But anyway, okay, we got reaction here. I would say she's probably in the feminist movement because she cares about social issues, and feminism is a social issue.
So you think that's more probable?
Yeah.
I really thought you would get this right. This one's so... I genuinely thought you would get this right. This is...
What is it that it doesn't matter?
Which is more probable, that Linda is a bank teller, or that Linda is a bank teller active in the feminist movement? Think about this.
Oh, okay. So it's just the fact that, well, then it would be that she's a bank teller, because you're adding less qualifiers to it. It's more probable that she is just a bank teller.
Yeah. Because it has to be. Because there's less constraining factors.
Yeah.
That is a just simple probability.
So in my mind, I reduced it down to simply,
which sounds like she would be.
Which would she associate herself with?
Right.
Yeah.
Well, I genuinely thought you would get that one.
Well, maybe I'm too stupid.
Most people also don't get that one. I did get this one, but I also have been a math brain forward the last couple months. So
I guess in my mind, for whatever reason, even though we were just talking about probabilities, in my mind, I was, instead of thinking what is more probable, I heard it as, is it likely that? Or something, which is the same thing.
Which is the same thing. The answer would still be just,
which is the same thing. But colloquially, people say, like, would it be likely that this is?
Well, yeah. Well, most people also don't hear it as it actually is. Most people take it as just another social situation and answer it as such, whatever they feel like would be correct.
Linda's a stupid.
No, it says here she's very bright.
Anti-nuclear energy person, probably. Anyway, so.
Yeah. So
what do we care what she thinks, really?
So yeah, that's just another people. They don't actually listen to the question. They just answer what feels right. And so did you.
Yeah.
And I genuinely thought you would get that one, because that one's kind of easy. If you just listen to the question.
Nah.
All right. This one's tough. This is like the first one. We're going to have to do a little thinking here. Mental image here. Be prepared. Newcombs Paradox. Okay. You walk into a room with 2 boxes. One box you can see, it is transparent, has $1,000 in it.
Give it.
The other box you cannot see inside, the mystery box.
Mm-hmm.
You can take just the mystery box, or you can take both boxes. There's a supercomputer that made a prediction based off of if you would take both boxes or if you would take just the mystery box. It predicted which one you would do.
Mm-hmm.
If the computer predicted that you would take just the mystery box, then it would fill it with $1 million. If the computer predicted that you would take both boxes, then it will not fill the mystery box with anything and it will be empty. The computer has successfully predicted the behavior of thousands of people before you.
Mm-hmm.
So it's extremely accurate. The computer made the prediction and filled/did not fill the box before you ever walked into the room. Do you take one box or both boxes? You take mystery box or both?
The computer.
You can ask as many questions, but this is not if I give you more information, then this isn't like the first one. Then there isn't a right answer here. This is not like the first question.
So the computer knows my actions. It was what it was. What I am going to do.
It made a prediction on what you were doing.
It's made a prediction of what I'm going to do.
Yeah, and it successfully predicted thousands before you what they did. If it predicted that you would take just the mystery box, then it filled it with $1 million. If it predicted that you would take both boxes, then it left the mystery box empty. And it made this prediction before you walked into the room.
And before I walked in the room, I'm going to ask questions. I know you love it when I do this.
I just said you could ask questions.
Right. And you're going to love it even more when I do. So,
this is not one of those thought experiments.
Do I know? How do I word this? Do I know what's going on with the computer funky business?
Yes.
Okay, so I know all of that.
Yeah.
Before I walk into the room.
You know this computer is there. You know he predicted you.
I mean, why would you not take the mystery box, right?
Why?
Because of my... So if the computer predicts that you take the mystery box and you do, you get $1 million.
But it made the prediction before you walked. It made the prediction and subsequently filled or did not fill the box before you walked into the room.
I mean,
think out loud here.
Yeah, I'm thinking.
Not out loud.
I'm thinking internally because my words aren't concrete yet. Yeah, I think you take the mystery box, and I think you take it regardless of the prediction. I would say that the computer should predict me to take the mystery box, but you don't know that. You don't know if it's going to do it or not.
Well, you know that it made a prediction, and you know that it's extremely accurate.
Yeah.
But you also know that the computer made the prediction before you walked into the room. Is the money's not gonna... The money's there or not when you walk into the room.
Yeah.
Meaning if you take both boxes, you're either going to get $1,000 and nothing or $1,000 and $1 million. And whether you choose to take it or not is not going to change that. The money's not going to...
Yeah, that was the part I was missing in my head. So
if you take the mystery box and he happened to have just gotten your prediction wrong, you're walking away empty-handed.
Yeah.
So let's say of the possibilities, there's fourfold. You walk in, the computer made its prediction already. Okay, so the money's either there or it's not. Your decision is not going to poof it into or out of existence.
Mm-hmm.
Okay, it's either in there or it's not. You take one box, you're either going to get $1 million or you're going to get nothing.
Mm-hmm.
Okay. Those are two of the possibilities. You take both boxes, you're either going to get $1,000 or you're going to get $1 million at $1,000.
Right.
Seems to me you take both two boxes, it's always going to be better no matter what.
Right. But if the computer predicts that you would take both boxes, you walk away with just 1,000.
Right.
But if that's, yeah, I guess it's true because if taking both boxes is the obvious choice, then, and it predicts that, which it probably is, if in your mind it is the obvious choice, it's probably going to predict that you will take both boxes, therefore not filling the $1 million box,
Right.
and therefore taking both is the only way to get 1,000 and maybe have a small shot at $1 million.
Yeah. If it happens to just get it wrong.
Yeah, which you probably won't, but yeah.
So do you?
So I guess, yeah, you take, I guess you take both. That feels wrong, but at the same time, or do you say frick it and you take the $1 million box because you're gambling at this point, right? But
Well, in what sense? Where's the gamble here? There's no
well, the gamble is you don't know what the computer predicted for you.
But you do know that it's an overwhelming majority that whatever you do, the computer predicted it.
Yeah.
It's not 100%, right? It's not God,
Yeah.
but it's been pretty good in the past.
I think I'm back. I'm flipping again. I'm back on you take the $1 million box.
You're one boxing?
I'm a one box guy because listen, if the computer is going to predict that you're going to do something, you ought to do it, because if you're going to do the other thing, then it has reason to have had predicted that you would take both. See what I'm getting at here?
Yeah. You got it out in the end. But
yeah, you got to if you're going to do something, you got to do it. Full send, right?
But here's the thing. If you're going to do something, changing your mind at the last moment isn't going to make the money all of a sudden go away.
Yeah, but
the money's either there or it's not.
I understand that, but here's the thing. It's the principle of it, right? It is. It simply is the principle of it. If this computer simulation is anything to be trusted, if it's anything to be believed, and you said it's really, really accurate,
Pretty good.
you need to be the kind of person that does a thing or doesn't do a thing, right? You know what I'm getting at here? If it knows your behavior and it predicts that you are gonna get the $1 million box, I guess maybe at the last second, then you could say, oh, and then do both. But
who's to say that it wouldn't have predicted that?
Exactly.
But here's the thing. If it did predict that, then just taking the one box isn't going to all of a sudden make that money be back in the box.
That's true. That's the gamble. That's the gamble I was talking about.
Yeah. Which would mean you should at least walk away with $1,000.
But it's going to know. Or did know. It already knew before you walked in the room.
Okay, well, here's the thing. This is historically the most... I'm a one boxer. I think if you take two boxes, you're absolutely idiotic. You need to be taking one. Like, the fact that I'm arguing for two boxes here right now, because that makes an episode, but if you take anything other than one box, I'm sorry, you are just simply wrong. You are simply wrong. I am going to be rich and you are going to be poor. And that is a fact of the matter. It just is. Like, the fact that people can think that they're gonna out the machine.
Yeah.
Like, I get the reasoning of the outcomes possible. I'm either making 1,000 or 1,000,000 and 1,000, and you're either making 1,000,000 or nothing, which means my outcomes always are going to be better than yours.
Yeah.
Are reasoning incorrectly. They are reasoning incorrectly because they miss the part where I could take 1,000,000 and you could take 1,000.
Yeah.
Okay. That's a real possibility too.
Well, that's the thing. So it's the difference between if you act if you act according to what the machine predicts for you, which if it's accurate, is gonna do it. Right?
Yeah.
If you are the kind of person that takes 2 boxes, there's not gonna be 1,000,000 in there.
Yeah, exactly. You just by saying you should take 2 boxes, you've already sealed the deal of being poor. Like, this isn't obvious. But here's the thing: this is famously the most divisive thought experiment of thousands of polls. It is almost exactly 50-50, 2 boxers and 1 boxers.
Yeah.
Because and both sides think it's so blatantly obvious which one's correct. Except I'm actually correct. 1 boxing is the way to go. If you think 2 boxes is the way to go, I hope you're happy being poor and not getting the 1,000,000, because it's just you think you can outsmart the supercomputer and thousands before you, but you're wrong. But here's the thing. If you rephrase this thought experiment into God predicted that what you were going to do, meaning there is a 0% probability that it's going to get it wrong, everyone's a 1 boxer.
Yeah. Yeah. No, that tells you something. It just, I mean, that outlines the maybe the distrust of a machine's prediction of you and people's.
Well, it's not even just that. When this is phrased in a way that there is any probability, whether it's a machine, whether it's some demon, whether it's, whatever, a group of the smartest social scientists in the world made the prediction, whatever it is, if there is a hint of possibility of incorrectness in the prediction, then it's split 50-50, 1 boxers, 2 boxers.
Yeah.
But if it is clear that it is God making the prediction, it's 1 boxers.
Well, I mean, just look, if you want to look at anything, look at the lottery. What a fraction of a percent of people.
Yeah, you're right. Literally, that's a perfect example. Literally, if there is, this is where the phrase, so there's a chance. So you're saying there's a chance. That's where that phrase comes from, is even if the probability is just overwhelmingly not there, people don't care. People don't care. They're going to try and play the odds. And
they're playing the short odds even, which is
the extremely improbable.
They're not even doing because getting the 1 box is playing the large odds, right?
Yeah, odds are that it's going to have predicted that this is what I was going to do, and if I commit to that's what I'm going to do before walking into the room and do it, then the computer would have known that. And if I would swap at the last second, the computer would have known that too, because it's obviously if thousands of people in the past were correctly predicted, surely some of them would have also tried to do that switcheroo, and it got that.
Does it change anything? Let's say the numbers, instead of 1,000 and 1,000,000, it was 1,000,000 and 10 million. Does it change anything for you?
Meaning, even if you 2 box, you're still coming out with life-changing amounts of money.
Yeah.
No.
You still 1 box it?
Yeah.
The reason I asked that is because all the logic still stands, but like, does it pull you
I'll
back?
say it does pull me closer to a 2 boxer.
Yeah.
It does pull me closer to a 2 boxer, because no matter the situation, I'm coming out. If I'm 2 boxing, no matter how small the probability, I'm coming out rich as frick.
Yeah.
And if I'm 1 boxing, there's a probability that I'm coming out empty-handed. Right. And that extra sucks.
Yeah.
If it was possibly 1,000,000.
If you miss out on 1,000, it's like frick.
Yeah.
Whatever.
So I think there is a number that you could get to that's high enough to where I would become a 2 boxer.
Yeah, just take the guaranteed money.
Yeah. because then the value of the money would stop meaning as much.
Yeah.
And what it would do is it would shift the emphasis from the value of the money off of the money and onto the probability.
Yeah.
The fraction of a probability, the consequences of the low probability become ever greater and greater and greater and greater, such that they overtake the consequences, the positive consequences of taking the one box.
Yeah.
Right. So I definitely, as you increase the value of money, the consequences of one boxing turning up with nothing also increase.
Yeah.
So there's a line of probability there that's like, but both goes up, and I think it's inversely correlated with the value of the money, which is why I think it's correctly set at 1,000 and a million.
Yeah.
Because I do think that should money amounts change, like if it was $1 and $10, everyone's one boxing, because it doesn't matter. No one cares about getting just the $1.
I do.
So I think the value is important here.
I think maybe instead of 1,000, maybe like 10,000.
10,000 a mil.
Yeah, because I don't know. Because to me, everybody's living situation is different, but like it'd be really sick to have $1,000, but that's a pretty negligible amount of money. Like I don't know the. I
mean,
for me,
it's
it's
a ton of money, but
in the sense of like if I lost out on the 1,000, I'd be like, shoot, that'd have been kind of cool, whatever. Yeah. But like I'm always going for the big bucks there every time.
Yeah.
There's I don't even care about two boxing. Like I just want the million, right? But if it was like if I'm walking away from 10K, that's a good amount of money.
I would still one box.
I still would too. Absolutely.
I say even at 10 million and 100 million, or a million and 100 million, I would still one box. But
yeah, no, even in 10K and a million, I'm still one boxing. But like it's gonna be difficult to walk away from a guaranteed 10K.
Yes, I agree with that. It makes the decision harder, but also if there are thousands that it successfully predicted in the past, if I present myself as the most predictable person ever, which I am because I know I'm one boxing, then that just makes me ever more confident that, I mean, the probability is 0.000 whatever chance that it's going to get it wrong. So like, I'm one boxing until the values of the boxes become very, very large. Or specifically, I'm one boxing until the value of the two box becomes so high such that I'm leaving with, I'm going to be rich anyway.
Yeah.
Right.
Like if it was like 100 million and a billion.
Oh yeah. Honestly, like I might just two box because for me, those are functionally the same amount.
Yeah.
Those are functionally the same amount.
You're not spending 100 milli.
I don't know what to do with 10 milli.
Yeah.
Let alone an extra 900 milli.
Yeah.
Yeah. I don't. Yeah. Right. Like maybe honestly, maybe I would still one box because I could like donate 900 milli to like Peter Singer's, whatever that website's called, GiveWell or something. The Life You Can Save. That's what it is. I don't know. Maybe I would still one box because I really am confident that it would know what I was going to do.
Be devastating to be wrong.
But here's the thing. Yeah. That's why I'm saying the probability, the consequences of that minute fraction of a probability where that it predicted wrong would be devastating if you could have just walked away with 100 million.
I think
devastating.
I think at 100 million, I'm two boxing every day.
You think so?
I think so. I think that's high enough. And again, I'm a one boxer. I'm a one box stand for a long time. But once you get up to $100 million, I'm not risking it. There's no way.
Even a minute fraction of a probability, you're not risking.
Yeah, because I mean, like we said, what am I going to do with $1 billion? A lot.
I just said what I could do with $1 billion.
Right, but what could I
just give it away?
But also that fraction of probability that because I think maybe in my mind, I'm thinking that the machine knows that like I'm really afraid of getting nothing. So the machine predicts based on my psychological makeup, let's say, that I am going to be really drawn to the safe option. And then I go, frick it, I'm going all in, and then that's how you walk away with nothing. But again,
exactly, that's how you walk away. Well, my psychology is such that I would be rich now over you, because I'm pretty sure I would steal $1 at a Billy and 100 milli.
There's a chance. There's maybe, but I mean, you could be wrong.
You say maybe, but the computer's done this thousands of times correctly.
Right? No, I'm not saying that is it going to be correct. I'm saying, are you being honest with yourself? Do you know what it's predicting about you? That's the question.
But even so, even if I'm super, super divisive on it, the computer's done pretty well with thousands in the past. So like, even no matter how divisive I am, even if I pick the $1, it's
right. But if you have indecision, let's say you are in turmoil about the decision, because I mean, again, you're not in the situation. You don't know how you're actually going to feel.
No, I don't know.
Until you're presented with that much money.
If it's 1,000 and a milli, I'm pretty sure.
I'm one boxing on that. Yeah. Like I said, I'm one boxing on that. I might be even one boxing on milli 10 milli.
Yeah,
but I'm just saying it
does make it harder as the value goes up and the consequences of coming out with nothing increase.
What I'm doing is I'm trying to be realistic with my own risk assessment and what I think the computer thinks about my own risk assessment.
We're saying consequences, but here's the thing: the consequences of you coming out with nothing are the same whether it's $1 and $10 or an infinite amount of money and an infinite amount of money. The consequences are identical. You're coming out with nothing.
Well, yeah, but coming out with nothing when there was $10 on the table is that doesn't really do anything for me. That's fine.
Coming out with well, I'm seeing this. I'm trying to reframe this. Your outcome is identical, no matter how much money was in the boxes. Should you come out with nothing, right?
Yeah.
So you're saying, meaning the consequences are exactly the same. The only thing that's making this so bad is our own disappointment in ourselves, I guess.
It's what could have been, right? Because, I mean, walking away with nothing whenever there was, let's say in the safe box, the one box here, or the two box guy, there was $1 or there was $1 million, right?
Yeah.
To walk away with nothing, that's a different situation. Totally different, right? Yes, the outcome is the same. You walk out with nothing, but you could have had $1 or you could have had $1 million. And the impact on a life is drastically different.
Yeah, yes, I see that, but I'm trying to narrow the view here on the only thing that's making this bad is yourself.
I mean, yeah. You can, if you focus on how the outcome was the same and it's no different really, you can kind of reason your way into being okay. Right, but I wouldn't be. I'm afraid that's a lot of freaking money. I think I would have an easier time being okay. I mean, I would get over it. I'm not saying like I'm not gonna like freaking, I don't know, ruin my life over this, but I am saying that like I'm gonna be really freaking distraught that like I could have, bought a home and
had 100 million instead of $1 billion.
Yeah,
yeah. I like, obviously I'm still human, and it would be worse for me had I had the chance at 100 milli, went for the Billy and got nothing, versus had I had the chance at 1,000, went for the milli and got nothing.
Yeah.
Like, obviously I would feel different in those two situations, But I feel like it would be easier for me to realize that the two situations are actually identical. And there is no real difference between the two situations because I'm now in the same situation either way.
I mean, maybe, but I think you'd have to be in that situation.
Maybe.
I think that's how you think you would want to be, or how you can speculate you might be, but I think it would be completely different.
You think I would be crying over myself, distraught?
I think you'd be very frustrated. I don't think you'd be.
Well, obviously,
I'm not saying you'd be in a puddle of tears, but I'm thinking over the course of the next several years after, you'd be like,
years? No, absolutely not. Are you what? Do you even know me? You think I would be soiling over this for years?
I think you would think about it at times. You would, be going to, I don't know, buy a home or buy a car or whatever, and you'd be like, frick, this could have been simple. I could have just had this money. Again, you're thinking that I'm saying that you are just like distraught, crying, thinking.
Okay, if all you're saying is I would think about it sometimes, duh. Yeah.
And it would be frustrating, yeah.
Okay, yeah. I'd be frustrated, I guess. Yeah. Duh. I thought you sounded like you were imposing how you would react onto me and then say that would last 3 years or whatever, several years.
I never brought up myself at all, actually.
Yeah, you did.
I brought up originally, but then we started talking about you.
That's what I'm talking about.
Yeah, no, I said how I would feel, then you started talking about how you would feel, and then I said, well, I think you're wrong about the way you feel. But, I mean, I suppose...
Maybe I am.
Yeah.
I think... I mean, yeah.
My only point is, if actually put in the situation, I think you would... The impact that this would have on you is higher than you originally presented it to be, with like, well, I could reason it to be, this is all the same and all that.
Which I also presented that it obviously would be different because I'm still human.
Yeah.
Which is what you sound like you're saying.
Yeah.
If I would just think about it sometimes, yeah, obviously.
Yeah.
Okay. Well, it sounds like you're blowing that out of proportion. I don't know what I'm doing next 2 weeks. So stay tuned. I might just keep doing easy stuff like this. I might do another math thing. We'll have to see. But are you a 1-boxer or a 2-boxer? That's the real question here. Because it splits in the original thought experiment, 1,000 and a milli. Because it splits 50-50 almost identically, side to side. And I want to know your reasoning for picking either option. And if it's genuinely, if it's 2 boxes, like what are you doing? Like just by having that idea, you're locking yourself. You are solidifying your $1,000 in making that decision. And please justify that to me. We'll see you in a couple weeks.
See ya.